Welcome to the ML in Production Reading Group's discussion of Chapter 10, Infrastructure and Tooling for ML Ops. This chapter is on all the infrastructure, both hardware and software, that you need to do the things that we've been talking about in the chapters up to this point. So, storage, provision of compute, setting up the development environment, and then not just running jobs sort of willy nilly, but submitting them to some kind of management system, whether that's something like Cron or Slurm, these older style of resource management tools, or something fancy and new like Kubeflow or Metaflow. And then also, lastly, sort of how to package all of this stuff up, not just the things in this chapter, but the things in other chapters about deploying models, storing models, and storing features, and versioning all these things, putting them in some kind of fancy special purpose database, so that, and then wrapping this all up in a platform so that you have a good experience when you have lots and lots of ML teams at an organization. And then the chapter closes with a section, build versus buy, that talks about how you decide whether you're going to build something like this for yourself or whether you should buy an existing platform, the ones that are out there. This is a very hot startup space. There are a lot of unicorns and would-be unicorns in the infrastructure and tooling for MLOps world. So there's a lot of choices there in the buy space, and also a lot of examples to look at if you choose to build it for yourself instead. So yeah, that's my overview of the chapter. We can just scroll through and look through it, unless anybody wants to pick out a particular section that they really wanted to talk about. Containerization is a fun one, or orchestrators.
Maybe just go through it one by one.
Yeah, let's do it. Okay. So storage and compute here. We have to provide, if we're going to do machine learning, we need something to hold on to data, something to perform transformations and computations on that data. Um, so we have our storage layer and our compute layer. In general, nowadays, people, unless if what you're going to be doing is going to look a lot like a cloud, whether it's you have a private data center for doing stuff or whether you are using one of the public cloud providers. It's going to look a lot more like connecting to AWS than it is like running something locally. So it's relatively uncommon for any organization with more than one or two machine learning engineers to have local compute as a really important component um, of their system. I guess maybe the only exception would be sometimes people will get like a local computing thing just for like messing around and for quick debugging and really rapid development. They might get a machine um, for some of their engineers who would benefit from that. People who are more researchy, maybe, but everybody else is going to be using one of these, something that's cloud deployed. So some nice sections here on utilization and on like IO bandwidth and how to make use of your compute and your storage. This Make Deep Learning Go Burr from First Principles blog post is actually quite nice. I wrote a similar blog post that's about using the PyTorch profiler for uh, using the PyTorch profiler to like track your machine learning. Uh, like, sorry, spacing out there for a second, to track the operations on the CPU and GPU and see where you're bottlenecked and where things are moving quickly. So that's kind of the way to operationalize this. Use one of those. Use the PyTorch profiler or PyTorch Lightning's simple profiler.
I guess I'll make a comment on this page with that I didn't think of with that picture with the GPU instances on AWS. I didn't know that well, I guess I didn't look too much in detail, but that vCPU it's not like a CPU core. It's actually like a CPU. thread. And
Yes.
that was surprising to me. I didn't think of that, but now I'm gonna keep track of that. Important to make that distinction in case you have like data loaders that need less threads.
Yeah. Yeah. The vCPUs are virtualized CPUs, and so they don't behave exactly like you would like a normal CPU would. So yeah, it is worth definitely before you run a big training job, you want to do some like quick tests type things in to make sure that you aren't doing something really silly with your data loader that doesn't translate onto, or something very reasonable on your local machine that doesn't translate onto the behavior of an AWS machine. Has anybody used the TPUs on Google Cloud Platform or even with Colab?
I think I've ran it once on Kaggle, but it's
Yeah,
just like running a notebook and it goes
yeah,
to GPUs. It seems to be pretty powerful,
yeah.
but you
It
got to
se-
get everything working together. Like it wants, I think it prefers like some TF record as the input for fast IO loading. You got to get it in its right spot, and then when you get everything in its right configuration, then it works really well.
mm. Yeah, I think the other bit is that it is, I believe, easier to program TPUs and also to not shoot yourself in the foot with performance with TPUs if you're using JAX or a framework built on top of JAX, as opposed to frameworks in TensorFlow or in PyTorch. Dan mentioned in the chat that he could confirm that they're super fast. I don't know, Dan, if you were using PyTorch or if you were using JAX there.
The PyTorch GPUs, I think that's still in development.
Hmm.
I
You,
don't think it's really well vetted out. It's definitely pretty vetted out for tensor. Of course, Google did make the TPU at
yeah.
TensorFlow, so it makes sense.
Yeah. Yeah, so it looks like Dan was using PyTorch. I know that, Lightning does make it possible to use TPU acceleration, but, I have only used Lightning for GPU acceleration. But yeah, it can be really effective, and I think one of the recent things that was going around Twitter in the last 2 weeks was, Facebook posted the logbook of their large model. They trained a large multimodal model, and they like saved its they like share their engineering logbook about, handling crashes and handling restarts and loss spikes and all this stuff. And one interesting bit is some people who have been doing large language model training on TPUs said that it seemed like they were having way more trouble with their large GPU setup. That Facebook was running into more problems essentially than they would have had if they'd been using a TPU pod. So there was some back and forth on that discussion. It was kind of interesting. James Bradbury is one person who's on the TPU team at Google who was talking about that. Worth taking a look at if you're interested in really large scale neural networks to see what people have been saying. But at least right now, it does seem like the tooling's more mature for GPUs. So I usually just reach for GPUs for stuff, but that might change and is changing, I guess. Yeah, cloud computing, this, the one interesting thing I did wanna call out here was, it does seem like I was really shocked when I first saw this pattern of people using training on Google Cloud Platform and then deploying on AWS, and which so the idea being that your like web service, which is deployed, is based off of Amazon Web Services, but then training is in something like Google Cloud AI Platform. And just taking a quick look here at this Monzo blog, there's been some good blog posts coming out of these folks recently. They very they very explicitly are like, yeah, we do training and exploration on cloud, analytics on Google Cloud, and then all of production is in AWS. And that seemed insane to me because now you've got like two completely separate cloud providers that an engineer who wants to understand the whole thing now needs to know both GCP and AWS. I'm curious if anybody's run into this pattern in an actual organization that they've worked in, or run or set up a project where they used both AI, Google AI platform, or Kubernetes engine and AWS.
I haven't worked in an organization, but I did ask my brother's a software web developer. And I asked them, should I use AWS or GCP or something else to host like a website or something? And he said, go with AWS because with AWS, you can use Linux and it's more open source. But if you go to GCP, you're locked into their environment. So you got to kind of play by the rules. And it's,
Mm,
if you change it, like AWS, you could change from, because it's Linux, you could just go anywhere. GCP, once you're locked in, once you go on there, you're kind of locked in there. So I'm guessing maybe some people do their training on GCP and then they move their website development or their inference on AWS
mm.
so they can't get locked in or something. Or maybe they got a ton of credits for free on Azure or GCP, and that's why they do their training there. I've seen that at some startups. They just get like a lot of money and then they do all their training with GCP or Azure.
Yeah. Yeah, I do think people do sometimes make these decisions based off of where they can get the free compute. Um, and I guess if you're a startup, on the one hand, it's a pain to have to work on two clouds. On the other hand, you could maybe get credits from both, and then you get double
Yeah, and that works.
free
But I
compute.
mean, but if you have AWS, you're not really working. Well, depending on what you're doing, you're not really changing what you previous done because it's literally like a Linux box. So it's pretty common to everybody. But if you go to GCP, you have to learn their kind of like their terminal. So
Hmm,
so it's not. I think in AWS you're more open, but when you start going to GCP, then you start got to learn their.
interesting. Yeah, I'm more experienced with AWS than GCP, but um, yeah. Moving
Yeah,
on from
what I was shocked by is how come they don't have the full pipeline for separately. Like if you wanted redundancy, you would have your code like do the whole pipeline on two different platforms. But here they're separated. So you don't have there's still dependencies.
Yeah. So just moving on so that we make sure to cover as much of the chapter as possible. The development environment section is interesting around development environment setup. I think in industry, people are moving more and more towards standardizing dev environments as much as possible, just because people end up losing like entire engineering days or even weeks to like bugs that wouldn't exist if they just standardize their development environment. So Chip gives an example of like Python 3.8 versus 3.9 having a subtle behavioral difference. Similarly, like you can just run into dependency hell, just like package conflicts and things like that. And if you standardize your dev environment, that only needs to be solved one time by one person, and then everybody gets the benefits. And as people move more and more towards like containerized services for production and containerized training, you um like this also makes your development environment much closer to the actual running application or the actual final thing that you're trying to do, whether that's training or production. And so people have been heavily moving over to making basically everybody run Docker uh, in order to um, standardize development environments. And yeah, and the M1 Mac being just like one example of this. Just Apple releases a new computer. Now all the new computers you're buying for your developers just like can't install PyTorch. And that's something that you don't want to have to deal with as an organization. Um, and you'd much rather standardize. So I personally have like, I use Colab a lot for my development environment, which is kind of like having a cloud deployment. But then I run my own servers locally most of the time, and don't really do a ton of containerization for my development environment. I don't know if anybody has worked in an environment where everything's running in a container all the time. One interesting new thing on this in this direction is just in the last couple of weeks, Replicate which is a company that helps sort of support reproducible machine learning, released their library Cog to the public. Let's see. Let's check it out. Yeah. So Cog here just makes this Docker process a little bit easier for machine learning people. So they like abstract away the creation of a Docker file that specifies the container. So you have some control over it, but you don't like write the whole Docker file. They install CUDA for you, and then um, like and they'll set all that up. You can also like really easily turn it into a web service if you use some pieces of their library. They'll build up a little fast API based uh, prediction server with some nice little features, cloud storage, queue workers, all that kind of stuff. So this, if you are interested in using some containerization best practices, but you are not you don't want to lose like 2 or 3 weeks to learning to like understand GPU accelerated Docker, then Cog is probably a good choice to get your feet wet with Docker. Oh, what about GitHub code spaces? I've heard good things about GitHub code spaces. It's like Visual Studio Code, nice integration, obviously, with your repository stored on GitHub, and like um connecting to your CI really cleanly and basically giving this cloud development environment in a nice way. Um, has anybody used this these code spaces at all?
No, I have not.
Yeah, I think I've definitely seen some organizations where these. Yeah, it looks like other folks are mentioning in the chat they haven't used it. Yeah, I've seen some organizations where this is in place, but never used it myself. Yeah, from dev to prod with containers. Mentioning of Docker files. Um, yeah. Okay, resource management. Yeah, so up to this point, we talked about getting the like hardware, both storage and compute, then setting up the development environment, and now we're thinking about how we manage how many how many cloud instances do we have, how much storage do they require, what types of instances are they, and then also just like scheduling and running jobs on those things. That's all in the world of resource management. And this has become a really huge uh, field. I was gonna say time suck because it's become something people now spend a ton of time thinking about resource management and thinking about Kubernetes and schedulers and orchestrators on top of Kubernetes. And but it's a tough engineering problem to solve those things, and I guess worth it for making other developers' lives easier. So this resource management world of being a Kubernetes engineer is uh, is a big one these days. Yeah, ML workflows with and dependency graphs. So the basic thing is just to run a job every single day, run it every single week, a predetermined time, and know whether the job succeeds or fails. But really, in an ML workflow, we have a lot more complicated kind of relationships. Like we want to specify like if then kind of flows. We might want things to run on triggers or the behavior of other jobs rather than just at a fixed time. So cron is insufficient to schedule a machine learning workflow. So Chip gives this example of a workflow for ML that might pull data from a warehouse, featureize it, train two models, compare them on a test set, and then choose which one to deploy. So we talked about continual learning, and we know that in a really high stakes or tooled pipeline, comparing A and B is a pretty complicated step. So you can imagine this could get like way more complicated than what we have here. But even in this simple case, we're already beyond cron, and we need something that can handle this. And the usual way people think about this is that these are directed acyclic graphs. So their nodes are jobs, and then arrows represent dependencies. So I can only featureize the data if I have last week's data, and I can only train model A or B if I have that featureized data. So these kinds of dependency relationships are captured by these graphs, these workflow graphs, and they so these schedulers are like provide this feature for you. So you describe what you want to do in some domain specific language of that workflow uh, that or that yeah that workflow manager. Like you provide these nodes and you hook up the little arrows, and then it will run it for you. So I had last time I used this was when the hot tool was Luigi by Spotify, which I think is now deprecated. So it's been a while since I thought really hard about workflow orchestration. The but there's some discussion on tools here. Has anybody used any of these workflow managers? Airflow, Kubeflow, Metaflow. Not TensorFlow, of course, confusingly enough. Not that it's not that level of flow. It's a lot lower. Yeah, just taking a look at this Airflow example. Um, oh, nice. In the chat, Mert's saying that they tried Kubeflow in the ZenML workshops. Did you have a good experience with Kubeflow? Yeah, while we wait for their response. Yeah, this is what one of those workflows might look like in something like Airflow. So you're building this directed acyclic graph, you're building this workflow object here, and you're adding operations to it and saying what they depend on and what they use. Yeah, Mert's saying not a great experience with Kubeflow. I do think, yeah, these tools are complicated still, I think. And I think maybe this Argo workflow, I think this example is this is a famous example. I think I've seen this before outside of this book. This Argo workflow to flip a coin and then tell you whether it was tails or heads um, is, this is a lot of boilerplate to get just to get just one bit, one random bit. So, and in particular, yeah, a lot the ones that use YAML files, people have kind of a bad reputation, and people prefer to do it in a language like Python, where they can where they're more comfortable describing workflows and programs basically. Oh yeah, if you one reason maybe people have not tried too many of these things and have not gotten experience with Kubernetes is that you need a um, you effectively need a bunch of cloud machines in order to run Kubernetes in a realistic way. And so there's a mention of this Minikube tool for kind of simulating Kubernetes on your laptop. But I don't know if it's super great. There is more tooling for like as people start to do like this becomes a ever more tightly integrated component of people's workflows. There's a need for developers to be able to simulate the behavior of their Kubernetes to do like local development and like to do quick debugging and things like that. And so there are more tools for this. I'm not an expert in this, but I've seen people talking about them and using them for sort of like mimicking production at a smaller scale, whether that's on your laptop or with like a very small chunk of cloud compute. Um, so you could try and simulate the whole thing, the whole cloud, infinitely scaling elastic cloud world on your laptop, or in this Kubeflow and Metaflow, switch around and just try and make something that runs both locally and on cloud, which is, I think, the more common and maybe easier way to try and solve this. So we haven't Um, I haven't used either of these yet, but uh, I think they are definitely increasing in popularity. All right, down here at the end, the ML platform. If you join a really big company that has a mature ML function, so whether that's a like Google, Amazon, Facebook type place, or whether that's a just like a really ML centric or a really sophisticated ML team at an at a more traditional kind of company, these ML platforms they'll tend to have an ML platform. So a development setup that's kind of beginning to end managed with lots and lots of tooling, the kinds of tooling that we've been talking about throughout this in this entire book. That'll all be kind of like set up if you join a company that with mature ML. Um, and it's a little bit what exactly is in an ML platform is very different. Spotify has a different idea of what it means than Netflix, who have a different idea of what it means than Google. And so like there's not it's not super unified, but all of them have something that tries to manage all of this. And there are increasingly more and more open services, MLflow and Databricks. Um, uh, is one. There's lots of startups in this space. Weights and Biases is another. Then Amazon has AWS SageMaker for this, and then some parts of Google Cloud Platform kind of serve this purpose. So there's lots of options out there for solving these problems, but yeah. SageMaker. Oh, Vertex AI. Yeah, on GCP. Azure, of course, has one. Um, yeah. Uh, yeah. So this ML platform tooling. Yeah. Again, this is like big team scale software. So you got to kind of work on a big team to get experience with these things. Um, so I haven't used a ton of these tools. Any parts of ML platform that anybody wanted to cover?
I guess in this model deployment section, there's in the third paragraph where it
Mhm.
says when looking to deployment tool and support, consider how easy it is to do all-in prediction and batch prediction. Um, I guess I wrote myself enough to think about that when I'm choosing a, a tool to use. I didn't know, um, I didn't think of that before. And I guess there's also a part where it's like, further in the paragraph where it says, or maybe it's the paragraph where it says how easy it is to test your deployments. Some tool, I mean, for some tools, it's easier than, I guess it varies.
Yeah, yeah. So let's those are both great points. Let's dive in on both. So the first one was online and batch prediction with a tool.
Yes.
Yeah, yeah. And actually, there's kind of, in my view, there's kind of like three things here, which the next sentence mentions, which is you have online prediction, which is just like you send information to a model that's like like a microservice or whatever, and you send a an image and then out comes a caption, or you send text and then out comes the text in a different language, and that like under the hood that might look like the model is just running one like a backslash one through the model, whether it's on CPU or GPU. A lot once you get up to a higher scale, you probably want to take, all the requests that you get in the last tenth of a second, batch them together and put them through the model all at once, and then distribute them back out to all the people who asked for them. So that's a much more challenging like infrastructural problem. It's more challenging to like make sure you get the right things back to the right folks. So that kind of like live batch prediction um, is already a separate thing that's gonna like maybe look differently, and be easier on some tools and harder on others. And then true like batch prediction, or batch prediction as Chip means it here, is like running it every single day, running it on like a really large, um, like every user, every song in the Spotify library, or every user who logged into Gmail this week. And those are you one of the reasons why that is hard is you might need like a fundamentally different like database and compute engine for that, to run a transformer on the description of every album in YouTube Music's library. And so that is going to also be very different on different platforms.
Yeah, it kind of reminded me of there's like Pierce I think it was a Yelp example how they do the predictions. I think it said they do batch predictions on their restaurant predictions or recommendations, and then they'll also do online predictions when a user clicks on a restaurant. They'll use um, rec- online recommendation or prediction for to recommend what to eat at a restaurant.
Mhm.
But they kind of do both.
Yeah.
But then I was thinking, okay, if I want to remake a Yelp, I probably should choose a tool that easy to do both of these or combine them together. Otherwise, like you go 1 year down the line and you're stuck. You can only do one. You got to
Mm.
build it or you got to swap to a new tool.
Yeah.
That could be a big change. So maybe like an early decision can help a lot further down the line. That's what I was thinking when I saw this.
Mm. Yeah. Yeah, then the second point that you brought up was testing, and specifically not testing like software testing as people normally think of it, where you just want to check for bugs in your deployment, check for bugs in your web service, but like test in production, as we talked about it in the previous chapter, which includes shadow deployment, canary releases, A/B testing, bandits, all this kind of stuff. That some deployment services are going to have that like built into them, like the really sophisticated ones and the really ML oriented ones. Like I believe SageMaker has SageMaker experiments or something like that. That's like at a very high level specify the kind of experiment you want to run to compare two machine learning models, or to like A/B test two different colored buttons on your website, and like that is done very like cleanly and at a high level. For other, if you're doing everything yourself, with um, just like deploying web services, you would have to write that logic. And so depending on how much you want to do this kind of sophisticated testing with shadow deployments, etc., you might want to choose a more ML, like a very ML oriented, experiment based kind of platform.
I thought the model store is pretty good too. If you have no knowledge or any experience in what Chip recommends for storing like the model definition, the model parameters, featurized predict functions, dependencies, data, model generation codes from artifacts tag. Probably a lot of lessons learned to get all these. And I thought that probably gonna save me a lot of time down the line, just knowing what others have done or have at least like resolved to doing for saving stuff.
Yeah. Yeah, I just ran into this problem literally this morning before the meeting. I was trying to just I have a model training. I wanted to check in on how it's doing, do some kind of interactive testing that I didn't want to incorporate into the actual like training loop, into the logging and metrics in the training loop. And I ran into the problem of like the model definition and the featurize and predict functions were not like arranged in a way that made it easy to go from the checkpoint that I had to a model that could do inference. So it is really important to get this right. And while there are lots of nice checkpointing services in PyTorch and PyTorch Lightning, and there's like things for saving and distributing models. there's just kind of like a software engineering level thing where you need to structure your models correctly so that this is as easy as possible. So that for example, the definition of the model doesn't depend on having the data around, right? Like one cheap trick that people like to use is like the input shape for the network comes from the data set. But then that means, and that like reduces the amount of duplication. But then that means if you want to recreate the model, you need to have the data set around. So that kind of thing, these featurization and prediction, these two things on the beginning and the end of your model. How do I go from an image to a tensor? And how do I go from a tensor of logits to a prediction? Those two things are both um, like something that you need kind of like independently of the model or like almost independently of the model. You need to be able to manipulate these things. You probably want to separate those things out and maybe even in the end when you fully get this going, like wrap them as a separate microservice, as a separate endpoint, and run them separately so that making a tensor is done separately. Like making a tensor out of an image or tokenizing an input text is separate from the like model inference, like done on a completely different machine and communicated over a network, for example. But you can only do that if you clearly separate out what the featurization pipeline is and what the prediction pipeline is in your model, and kind of so that you can pull those things out and modularize them. And it's tricky, surprisingly tricky, to get this right if you're just thinking about training. If you're just thinking the way a lot of people are used to thinking about their machine learning code, which is just about like how do I get the thing to make the loss go down. So I think I'm definitely going to come back to this section again and again to think of like when I'm like building model APIs and thinking about model storage and things like that. So I wrote a little comment about places where I've seen this pattern of featurization and prediction pulled out separately.
I think I've seen the reverse too, where they try to combine it together to reduce the modularization so that you have less people trying to mess it up. So you get less flexibility, but you reduce someone from tampering uh, your model and messing up the pipeline.
Yeah,
Uh,
I think it's really difficult to do development if it's all like tightly intertwined
oh, I mean,
with like tokenizer, model, and output. Like if I want to make if I want to make a slightly different version that does the prediction slightly differently, there might be like assumptions and interdependencies between the tokenizer and the predictor that are hard to see because they're separated from each other.
okay.
Or sorry, because they're all intertwined in
I,
one giant class.
yeah,
Yeah.
I was coming from a computer vision standpoint where
Mm.
you may want to stick your data augmentations into your model, your regular model, and stick them together.
Mhm.
I guess I'm not sure on the NLP.
Yeah, with yeah, I could definitely go into a lot on this. So yeah, we can chat about that later. I think um yeah, with things like compilation and like reuse and yeah, there's implications for how you design your data loaders. But I do want to just quickly touch on build versus buy in our last minute or two here. Um, yeah, this like in the end, when you get to the point where you're actually working in teams, building products, machine learning is not special. Lots and lots of other parts of computer science, whether it's databases, web services, any large application, there's gonna be these platforms to solve the like problems that come up during development. And so one of the most important features for somebody who's making these kinds of decisions at a startup or is working inside an organization that's like considering using platforms is deciding whether you're going to build it internally or buy it. So this build versus buy dilemma comes up all over the place. So there's lots and lots of people writing about this. It's worth reading what people have learned in other disciplines, other areas. Machine learning platforms are still so new that there aren't really that many things written about build versus buy for ML platforms. So it's valuable to get this perspective on what things to use to make this decision. But it is 10 o'clock Pacific, so that's the end of the official discussion time. So I will see the rest of you in our next iteration. No longer reading this book, but working on something else, a new project for the ML in production group. So I'm looking forward to that.